Hello everybody! In this tutorial I'm gonna do an decal in HDRP and it's gonna be totally procedural and it's gonna be interactive, so you can see here there are splashes from the ball bouncing on it, and of course you can change colors and size and shape of it like this and opacity. So no textures, so let's get started. So first we're gonna start in a fresh scene. So let's start with a rendering HDRP Decal projector and place it in the center. And I'm just gonna delete the old files. So we're gonna make from scratch, create shader graph and HDRP and decal. Mhm. And we're gonna create a material with the same name, and this one gonna be added to the decal projector like this. So the first thing we're gonna do is to make a circle in here, and we could do a ellipse like this and move this one around, but we're actually gonna do it ourselves from scratch because we need to control this one much more. So the way to do it manually, we just need to do UV and we're gonna do a distance, and we're gonna actually just measure the distance. So actually we're gonna split this one and make a vector 2 of it. And put this one in a distance, and the distance. So we have the x and y values here, and we're gonna, this distance gonna measure from 0.5, 0.5 from the middle here, and then we get the distance. And we take 1 minus, and we're gonna use a really nice node that's called color mask. And we're not gonna have it in the range, but we're gonna have it in the in like this. So this is really nice because if we change the mask color to 1 and we change the range here, we can also change the fuzziness and so on. So this is really nice. So we're gonna use this one instead. And if we plug this one into base color, bam, we have our own circle. So we're gonna also add this to the MAOS alpha. So we actually masking metallic, alpha, and smoothness, and something else, I don't know what it is. And also alpha over here. So this is actually going to be a color like this. And this color going to be, we're going to do green. That's nice. So here we have it. So we're going to expose this range and fuzziness. So I don't know how this node work inside, but I figure out that if you do, so we need float, and we need it like size. And we also need a sharpen, and all these gonna be slider, all of them. We're gonna have opacity later on. Spell it right. Opacity. And we also gonna have noise amp. So the first thing we're gonna do here, the range, that's gonna be the size. So we're gonna put the size here, and sharpen we have here. So if we in size put a value and sharpen, put the value. So what happens is if we do size smaller, but we want it sharper and stay in this size, we need to do this. So so what I'm trying to say is that you need to balance these two out to control the size and the sharpness. So to show what I mean, we're gonna have a lerp, and if we have the size in the B and we have a 0 value here, and we actually take the sharpen in here in the slide time and put that in the range, and we copy this one and we do just the same, but this time this one gonna be 0 and this one gonna be size, and we plug this one in here. So what happens now is if we do size, it's the same with size, but if we now use the sharp, it actually sharpen but keep the size. So if we lower or higher, we keep the sharpness. So these things balance out each other, so we have really nice way to control the size and sharpening, and that we didn't have with the other ellipse. So now when we have this thing, we're gonna add some noise. So if we save now, we let's see, and if we have this one, so we have the size and we have the sharpen. These two doesn't do anything yet, it's going to be later on. You see here sharpen works perfectly, and what we're going to do, we're actually going to add some noise. So how this works is that this value here, distance, is reading from the center, from this center to here. But if we offset the UV, this point here will be offsetted and maybe read the value over here instead with a noise, and that make everything noisy. So we actually need to add the noise not over here but over here to make it work. So we're gonna just add a simple noise, and we're also gonna have an UV, and I'm gonna do put it in here. Let's go for 40, I guess, and we're gonna remap this, because this one, if we add this one in here, this value is from 0 to 1, but we need to remap it from 0 to 1 to -1 and 1. So that means that our red. I think it's a X. So X, if we add to the X, now you see there's things happening here. It's way too strong though, but now we're only adding to the X. And well, we're just gonna do it one noise per channel, because otherwise we're gonna get this dragged effect that we don't want. I'm gonna show you what I mean. It's hard to explain. But first I'm gonna do this finished. So what's happening here is that we need a noise amp. So we're gonna do a vector 2. We're gonna negate. So this one, so what's happening here is that we are creating these values with this noise amp. So this is -1 and this is 1. And we put it in here, noise amp 1, right? We got the same value. But if we now, so it's too strong, so now in the noise amp we could just lower it to 0.5 maybe, or 0.1. Now you see there is more noise. So if we save this one, you see we're starting to get this noise right. So now you maybe wonder why we don't add this to both X and Y. I'm going to show you what happen if we do the both. So if we add it, so let's say we do like this instead. We add it over here, the noise is going to be added like this. And if we now change the noise amp, you see it's getting dragged in this diagonal shape like this, right? And that's because we're adding the same value to X and I. Because we're negating the same value, we get -0.5 and -0.5. So now we need to have two different noises for each axis. And it's very simple, because what we just need to do, first off, we're gonna change this back to only one axis like this and save. So now we only have it on the X axis. We're gonna add it in the I. And we just do it with this, just copy this one down here. We're gonna have an add here too, like this. And we'll have it here. And we just remove that one. So here we have the top noise. And down here we have the other noise. We're gonna do it like this. Looks prettier, I like that. So have it like this. So we just need to offset, because at the moment it's exactly the same noise, so we're gonna have the same diagonal. If I save now, it's gonna be the same problem, because this noise is exactly the same over here. So what we could do, if we just add here, and we just, well, actually we're gonna do like this. So vector 2, if I add vector 2 first, it's going to be an add for vector 2 and not for vector 4. As you see, it's a 4 here. So now if we just offset the UVs, it's going to sample the noise in a different place. And just by doing this offset in the noise for the other channel, you see now the noise is actually going in all directions. So that's super nice. So now I got this splash ready. And of course we can maybe just, if we take the decal and just scale it up, 3 by 3. See, it's easier to see, a little better. That's nice. So, and we have the noise. So let's see what we're going to do next. So now we actually need the input for, we're going to have this, if I just take these ones, copy and paste, and this one, we're going to work with a dot that's going to represent where the splashes go. So if we just take this one, and let's see, and if we so what's happening here is that we have 1 here and 0 in the edge, right? So if we multiply this one, well, actually we just do sine first, so I'm going to show you this thing. And if I do sine and we put it in the base color for now, there's actually not really much happening. But if we do a multiply, and before the sine we add, so the value from 0 to, actually from the value from 1 to 0, if we multiply it by 10, it's go from 0 to 10. And when we do sine, it's going to go from 0 to 10 and divide and transform it in through the sine to get these waves, right? So if we just crank this up, we can just decide how many ripples we want, right? So let's go for 50 now, and we can also, let's see how to do this. So if we save here, now we got the ripples, right? And if we do the multiply, maybe 100, save it, we got even more. And and what we also want to do, we want to have a time to animate this stuff, right? So now we want this value from 0 to 100 to have the values always increment, so these ripples will go outwards. So if we just do the values and add time like this and save, you see we got ourselves ripples. Maybe you don't see anything happening in your decal. Your decal is not animating, and make sure that you have this always refresh on, right? Because if you don't, it might look like this and you don't understand why aren't my shader animate. So tick this toggle on and you will see it in your scene as well. So this is nice. And so what we want to do is to have some kind of speed controller. So this time we multiply maybe with 20. So the time is 20 times faster, and we save it. And now you see it's more ripple speed, depending on what you want. So that's nice. So now we're gonna do something important before we get into some problems. If we move this decal around, I'm gonna make more of them. So this one gonna be scale 1, and this one over here gonna have 3 by 3. This one gonna be 5 by 5. So when we have the decals on different scales, you see the ripples are different sizes. So we need to address that with adding some scale. And the way to do that, and we're gonna add, let's see. So we need to change the amount of ripples. So this big one needs more ripples. So because it's scaled here, size 5 by 5, we can actually do it with an object like this. And we can read the position and scale. So let's say the size here. So if we do a float and do 100 here, and if we do multiply, and we take the scale and we split, we only take one. No, we don't take in consideration if you do it like 5 by 10. It needs to be square. So if we just do like the width 5 and we multiply it, so it's going to be 500 in this one, and it's going to be 300 in this one, and 100 in this one. And if we save, you see, regardless the size, it's going to be the same size. So that's nice. So we're going to continue in the next part and add some more features and scale and stuff, and start to move this around and stuff. So see you in the next part. Thank you so much.